Hi students, this video will cover the 4.3 Applying Concepts homework that you did the other night. We will have a chance to go over this in class, but I just wanted to get this information out to you in case you were studying over the weekend or wanted to take a look at it. So evaluating these two wheels, we know that in order to calculate the mechanical advantage, we're comparing the distance that your hand travels around the wheel compared to the pin in here. So with any steering wheel, there's like actually this this pin that goes all the way back through the dashboard that then turns the wheels. So obviously you can't see that or anything because that's why you've got a whole dashboard and everything. But you use, in this case, the Ferrari's steering wheel. You put your hands on that and turn it around, which then turns the axle, which goes through the dashboard. Here, this is an old-fashioned, like pirate-looking wheel. I think it goes down into a well, hence the bucket or something like that. But in either case, if we're talking about doing the same work, evaluating the two wheels, we would look at which wheel is larger compared to the size of the axle. I don't have my Surface Pen, so I'm just kind of using the cursor, and I typed in the answers. Since both of the axles are 0.1 meters, they're both the same size. That means that we can just compare the size of the wheels to each other. So since image 1 has a larger wheel, here it says it's 0.5 meters and it just looks larger, we know that that would be the tool that we'd want to use. So calculating the mechanical advantage, we take the radius of the wheel divided by the radius of the axle. So that's 0.5 divided by 0.1, that gives you a mechanical advantage of 5. And 0.3 divided by 0.1 gives you a mechanical advantage of 3. So we see there that image 1 makes the job 5 times easier, while image 2 makes it 3 times easier. Image 2 is still a good choice, right? The Ferrari wheel, you would still rather use that wheel than no wheel at all, but it's not quite as good as the pirate wheel. That's what we're going to call image 1. So one part that a lot of people either didn't answer or a lot of people just said, for when it says briefly explain why you calculate the mechanical advantage in this way, a lot of people just said, well, because that's the equation. Well, sure, but why do we use that equation? What is the point of that equation, and why is that the equation that we're using? So that should make you think a little bit deeper and actually show some understanding about what's going on here. So I've got a little explanation written up here, which is that we calculate mechanical advantage this way because we do work on the wheel and the wheel does work on the axle. So we're comparing the work that I do on the tool and the tool does on the object being the axle. Remember, we could remove that outer wheel, right? We could take the steering wheel in the Ferrari off, or we could take the pirate wheel off and attempt to turn the axle by hand, like we did with the door handle, right? We could remove that door handle and try to move it just that the pin that releases the locking mechanism. We could do that just by turning the axle with our fingers, but this would be very hard. And actually, we know how much harder it would be. 5 times harder if you're using the pirate wheel, and 3 times more difficult if you're using the Ferrari wheel. So essentially what this question was asking you to go back and think about was, yes, mechanical advantage is the input distance divided by the output distance, or output force divided by input force if you have those pieces of information. But why is it that, right? And when we're thinking about mechanical advantage, we're comparing what we do on the tool to what the tool does to the object. So thinking about the fact that we are spinning our hands around the pirate wheel, and the pirate wheel therefore spins the axle turning being the work that we want done, that right there is how much easier it's going to be. It's that comparison, right? So now if we move on to in number 3, unfortunately in playing your game last weekend, you got lit up and you will have to recover in a wheelchair for a couple of weeks. That was a rough game. Which ramp would you select for your house and why? Got some interesting answers, and there's no real wrong answer here. Some people said they wanted the one with the tread so it would be easier to walk up. Fair point. Other people liked the handrails. Again, fair point if we're just evaluating these based on kind of like the accessories that they have. Great answers. But if we're evaluating them based on mechanical advantage, we would want to pick the longer one. So option 2 is the longer one. It gets the same job done, right? If the job is getting up the stairs, and if you're in a wheelchair, you physically can't get up those stairs, option 2, you travel a little bit further distance, so the force exerted overall is less. In number 4, it asks us to calculate the mechanical advantage and explain why. So in option 1, it's a 2-meter length and we go up 1 meter. So the mechanical advantage is 2. Option 2, we travel a distance of 5 meters and we go up 1 meter, a mechanical advantage of 5. So this ramp makes the job 5 times easier. This ramp makes it 2 times easier. Both are good choices. Option 2 is a little bit better of a choice. So we calculate mechanical advantage this way for inclined planes as well as wedges because the work or the job done is the height, right? That's what we want to achieve. We want to get up that height. And moving across the 2 meters or the 5 meters is what the tool actually completes, right? It's what it helps us do. So let's think about what we do to the tool versus what the tool does. If we are acting on this wedge for 5 meters and it gets us up 1 meter, versus this one, we act on it for 2 and it gets us up 1. We are making a comparison once again between what we do and what the tool does, right? Number 5, it asks, what class of lever would you use for the following activities? You should briefly explain your thinking if you are unsure of your answer. So that's really just me giving you an opportunity to kind of justify what you're thinking and what you're talking about there. So moving mulch from your driveway to the backyard, some people put a 3rd class lever. While that is, possible, it's not a great answer because that would mean that you would have to move the mulch, the dirt essentially, from the front yard to the backyard, 1 shovel load at a time, right? So you'd pick up a shovel load of mulch and then walk to your backyard and dump it. Then go all the way back to the front yard and do it again and again and again. In reality, if you're spreading dirt or moving mulch or whatever the job is, you're going to probably move a couple hundred shovel loads worth of dirt or mulch. So if you have to move a couple hundred loads, that means you're going to have to walk back and forth 100 times. So not the best choice. A better choice might be a 2nd class lever, meaning a wheelbarrow, right? Because that way you can load, using a 3rd class lever, just like in option B here, you can move dirt from that pile of dirt or from the mulch pile into the wheelbarrow and then wheel the wheelbarrow, the 2nd class lever, to your backyard. So letter B, the best choice would be 3rd class. You move the load, the dirt is at the end of the shovel. And 5C, there's a rock at the bottom of the hole. You want to remove that rock to plant a tree. You're going to use a 1st class lever, meaning you're going to use a shovel as a pry bar, right? You're going to pry that rock out. The load will be at the end, the input will be at the other end, and the fulcrum, the fixed spot where it twists from, is going to be like the edge of the dirt pile or the edge of the hole there. There was a previous video that showed a 1st class lever being used as a shovel, a 1st class lever, a shovel getting a rock out of the bottom of a hole. That happened in a previous video as well. So let me know if you've got any questions, and again, we will go over this in class, but this was just to get you started.